Dear students, welcome to virtual classroom of Municipal Corporation of Greater Mumbai. I am Sreekumar. The class is for 10th standard students. Subject is mathematics. Let me begin the class.
Dear students, exams are coming close by and you need to get ready for final assault, I would say. For that, the most important thing is making the fundamentals strong and approach confidently. Many questions repeat in question paper, but there will be new questions. So ultimately, how will we face the situation? The situation can be faced only and only if you are confident. The confidence comes when you are thorough with. And this is a revision on lesson number 1, similarity of your maths part 2. You studied about property of three parallel lines and their transversal. You should remember that. Property of an angle bisector of a triangle. Basic proportionality theorem or Thales theorem. Converse of basic proportionality theorem. Apollonius theorem, application of Pythagoras theorem in acute angle and obtuse angle, then similarity, the name of the chapter itself, properties of ratios of areas of two triangles, similarity of triangles, similar triangles, similarity triangle theorem, area of two similar triangle, areas of similar triangles. All these things which we studied in this chapter, I am going to make a quick revision and giving you a few examples which I have taken from previous question paper. Before getting into the examples, let me remind you the first point you studied was ratios of two areas of two triangles is equal to the ratio of the product of their bases and corresponding heights. You should remember, as far as ratio of areas of triangle concerned, we have to consider about the base, how do they, and the height is drawn from the base to the opposite vertex. Correct? Area of two triangle, again, area of triangle with equal heights will be proportional to their base, and with the equal base will be proportional or with respect to the corresponding heights. Remember that. This is one point you should remember. Basic proportionality theorem. The theorem says that if a line parallel to a side of a triangle intersect the remaining side in two distinct points, then the line divides the sides in the same proportion. You remember this, you know this. This diagram has help you to remember it very clearly. Here is a triangle and here is the triangle named as ABC, right? And here the line L is parallel to side BC. In such a situation, we proved that this particular line, which is parallel to one of the side of the triangle, intersected two points P and Q. So naturally PQ, PC are parallel. In such a situation, AP upon PB will be equal to AQ upon QC. This is the theorem. This theorem has been proved. You either will get a question to prove the theorem, or you may get a question to apply this theorem. I said to prove the theorem you should know to apply this theorem. So for that, when question comes, you should find out whether any parallel to one side is given in the question. Triangle is given, line parallel to one side, guarantee, basic proportionality apply, karna hai. Okay, let me go ahead. Property of an angle bisector of a triangle. This is also another theorem. The bisector of an angle of a triangle divides the opposite sides opposite to the side opposite to the angle in the ratio of the remaining sides. बहुत लोगों को याद आया होगा, बाकी लोगों को डायग्राम से याद आएगा. What is it? Here is a triangle ABC. Again, ABC, and C is ABC. This is C. C is having a bisector. There is a bisector which divides the angle C equally, and it divides the opposite side of that angle AB here. It divides because it is intersecting here in such a way that AE upon EB, that means this much part upon this much part, is equal to CA upon CB. This is the theorem. Again, either theorem may be asked to prove, or you will apply the theorem in a question. So what you will check for? If theorem is asked to prove, you will prove it. You should learn it. And if application comes, think. In the question, there will be terms like this. And the question will be having triangle. Or if these are not given, triangle will be there. It will be talking about a line which is intersecting a side in a particular ratio with respect to angle. That means you should get the clue. Oh, this is the application of property of an angle bisector of a triangle theorem. ये आपको तभी strike होगा. Property of three parallel lines and their transversal. Look at this. Three parallel lines, LM and transversal. One is this is second transversal. Think about first one. It is divided by or intersected by the parallel line, or parallel line is intersected by the transversal. And if you consider, it is intersected with A, B and C. Right? If I write AB upon BC, just like in the case of triangle, then PQ and QR also will be having same ratio. So the theorem says that the ratio of the intercepts made by a transversal by three parallel lines is equal to the ratio of the corresponding intercepts on any transversal by the same parallel line. That means if you have one more here, this is extended here, the ratio of, if I write P, Q, R, A, B, C, okay, na? S, I am writing here, PS upon ST, PS upon ST will be equal to PQ upon QR will be equal to AB upon BC. So that particular ratio is maintained by all such transversal. That's it. Again, application will come in questions. The name of the chapter is similarity. So a lot of things about similarity you should remember. First of all, similar triangle, and we are having test of similarity of triangle, AAA test, where all three angles of one triangle, in the case of similarity, equivalent. AA test, equivalent. SAS test, SAS, sides came, then the words will be proportional. Sides will be proportional. Angles will be equal. Remember, sides will be proportional if triangles are similar. If there are two similar triangles, one is this, roughly drawing, this is similar. If this is 2 centimeter, this is 8 centimeter. If this is 3 centimeter, this is 12 centimeter. If this is 5 centimeter, for example, this will be 20 centimeter. But if this is 60 degree, this also will be 60 degree. Understood? If this is 70 degree, this also will be 70 degree, equal. Then this will be 50 degree, this also will be 50 degree. So when it comes to angles, it will be equal, and when it is sides, it will be proportional. Theorem of areas of similar triangle. Area of similar triangle. When two triangles are similar, the ratio of the areas of those two triangles is equal to the ratio of the square of their corresponding sides. Square of the corresponding sides का ratio और किसका ratio से related है? Area से related है. Ratio of area से related है. There are triangles here. It is given triangle ABC is there. There is another triangle PQR is there. Similar triangle. Please understand. That's why the symbol here. And we have made it into more triangles. ABC and PQR are two triangles. These are perpendicular drawn. That is height of the triangle. And this angle is equal to this angle. B angle, R angle is equal to C angle. Naturally, P angle will be equal to A angle because they are similar triangle. Angles will be equal. Sides will be proportional. And we proved that if you are considering the area of the triangle ABC and the area of the triangle PQR like this, compare it, then you will get AP square upon PQ square corresponding sides. BC square, this one, and QR square, then AC square and PR square. They will be having same ratio. Ratio of the squares of the corresponding sides will be maintained. It will be same, equal. Remember this? Two things. One is proof, another is application. When it comes to application, there will be words like area in the question. There will be words like similar triangle in the question, or something will be missing. Now let us try to solve some sample questions which have come in the previous year. In the following figure, in triangle PQR, segment RS is bisector of PRQ, and if PS is equal to 6, SQ is equal to 8, PR is equal to 15, find QR. Okay, now how to solve this? We have to look at the question, take time, read the question, imagine, idea should come in the mind, then we can proceed. Certain things I would like you to notice. In the question, there is a word bisector. Here you can see that marked. You can see the bisector. You can also see the reading of which part of the triangle is given. Then we segment RS, if you look at RS, bisects PRQ, that is given. Segment RS bisects angle PRQ, given. Right? Now, angle bisector property just now you studied. When such angle bisector, it will be having a proportion 6 upon 8, 15 upon 6, x upon 8 will be proportionate. That is angle bisector property. So how can I write it? I can simply write according to the angle bisector property, PR, this side, upon QR, this side, is equal to PS upon SQ. That is a theorem according to angle bisector theorem. In this, PR is given as 15, QR is not given, that is what is asked, is equal to PS is given as 6 and SQ is given as 8. You can solve it and you will get the answer 20. Understood? This way we will apply the theorem to solve the situation. Students, here is a question. In the following figure, RP is to PK is equal to 3:2, the proportion. Then find the value of area of triangle TRP with respect to triangle TPK. The question is, there is a ratio between the length of RP this is RP and this is RP and PK. There is a ratio. That ratio is given. Now the question is, what is the ratio of the area of TRP with TPK? This is the question. So we have studied certain theorems in the lesson, especially the properties of ratios of areas of two triangles. The theorem tells that, what is the theorem? Properties of ratios of area of two triangles. Now we are asked to find out the ratio, the value of these two triangles whenever we compare the area of two triangles according to the theorem we studied. These two triangles, which are the triangle TRP and TPK, both are on the same base, and this particular vertex, if you consider, as far as TPK and TRP is concerned, a perpendicular line, if we draw from here, this will be the height of it. So these are two triangles but having common height or equal height. This is common. So when the height is common, the ratio of the area of those two triangles will be purely depending on the ratio of their base, and it is given 3:2. If we think 3 is PK, 3 is PK, RP is R from here to here, it is 3, and this is equal to 2 if you convert that into numerics. So the ratio will be area of triangle TRP upon area of triangle TPK. We have to write as the ratio of RP upon PK or any such corresponding side, and naturally it becomes 3/2. So the answer is 3:2 only. But this particular theorem we have to write below it according to the properties of areas of two triangles. Or you write the theorem itself. What is the theorem saying? In two triangles, with common height, then ratio of their area will be as per the corresponding base. That you write fully. Here I have a limitation. The theorem you have to write completely. You know it. Here is another question. In trapezium PQRS, side PQ is parallel to side SR. AR is equal to phi times AP. AS is equal to phi times AQ. Here is AS. This is not small letter, AS. Then prove that SR is equal to phi times PQ. The trapezium is PQRS. So I have to complete this aspect. Trapezium. See. Now it is trapezium PQRS. PQ side is parallel to RS. Yeah, SR. AR is phi times AP. AR is phi times AP. Then it is given that AS is phi times AQ. You are asked to prove SR, this base like, is phi times PQ. Again from the ratio of area of two triangles, we will try to solve it in a different way. PQ is parallel to SR is given. It is also given that AR is equal to 5AP, AS is equal to 5AQ. We are asked to prove that SR is equal to 5PQ. This we have to prove. If you consider the triangle, there are two triangles. See this part, this part, this part, this part. They are belonging to two different triangles. Which are they? If you consider a triangle APQ and there is a triangle ARS, AP and AR. So we will write that first. In triangle APQ and triangle ARS, we have to consider these two triangles. We have to prove these two triangles are similar. Then we can say that their sides should be proportional, because proportion is given of these two triangles. One is AR AP, AR and AP. AR is here, AP is here. The other one given is AS and AQ, AS and AQ, and the question is on SR and PQ. SR and PQ. We can do that. Before that, we have to prove these two triangles are similar. That is our attempt. For that, we wrote the name of the triangle in proper order. Now, these two, let me change the color. These are vertically opposite angles. So I will write that first. Angle PAQ is equal to PAQ. In that case, PAQ. Then I should write it as RPQ. AS. They are vertically opposite angle. If I could prove one more angle equal, then similarity can be proved. It is given that this side is parallel to this side. So in that case, this angle are equal because this is parallel to this, and we can consider this as transversal. So the angle PQA and RSA, angle PQA is equal to angle RSA because they are alternate angles. We have to write that side PQ is parallel to side SR, and you can name QS is transversal. ये आपको लिखना है. So you proved that these two angles are equal to these two angles, and PAQ belongs to triangle APQ. PQA also belongs to triangle APQ, and RS is belonging to triangle AR. So that these two angles are congruent. So by AA test, we can declare that triangle APQ is similar to triangle ARS. The question is, we have to prove SR is equal to 5 times PQ. So in these two triangles only, it is given that AR is 5 times AP, AS is 5 times AQ. Naturally, the third side also will have the same ratio, but we have to write that. Now we can write when these two triangles are similar, the corresponding sides will be proportional. So in that case, SR and PQ are corresponding sides. SR is coming here, PQ is coming here. So we will write PQ upon SR will be corresponding to PQ from here, SR from here. So we can take AP from here, and if it is AP from here, this will be AR from here. AP and AR are given. AP 5 times AP is 1 time AR. Correct? If I write AP upon AR, it will be having a ratio same as AR and AP. That means AR is equal to 5 times AP. This is given. So AR is quite bigger. So this will be 5 times of this. So this is given. So this is applicable here also because corresponding sides. So we will write SR is equal to 5 times PQ. So this is the answer. Proof. Right hands proved. A question which had come in the previous year in the board exam. So this type will come. Okay, we will go ahead. In triangle PQR, points S and T are midpoints of sides PQ and PR respectively. If ST is equal to 6.2, then find the length of QR. In triangles, triangle PST and triangle PQR, the ratio of sides as per midpoint theorem. PQ one second. PS upon PQ is equal to PT upon PR is equal to EST upon QR is equal to 1 upon 2. Therefore, considering this, ST is given as 6.2 upon QR is equal to 1 upon 2. QR is equal to 12.4. We have applied the theorem of midpoints of sides of a triangle. Where application of Pythagoras theorem in acute angle is also applied. We will go ahead. Here is another question. What is the question? From the top of a lighthouse, an observer looking at a boat makes an angle of depression 60 degree, not 600. If the height of the lighthouse is 90 meter as it is given, find how far is boat from the lighthouse. This is what is asked. Consider root 3 as 1.73. AB is the lighthouse in the diagram. Correct? Boat is at sea. Correct? Observer is at A. Correct? And the angle of depression is this. And that angle of depression will be equal to this alternate angle if you draw a line. Now, from the figure, this is a right angle. If you think about tan 60 degree, is equal to of this. This is hypotenuse. We will write AB upon BC. Which is equal to root 3. This gives us clue. We have to go in that direction. That means BC is equal to 90 In this we know that AB is equal to 90 upon BC. So BC is equal to 90 upon root 3, or we can write that 90 into root 3 upon root 3 into root 3, multiplying both numerator with root 3, will get 90 root 3 upon 3, which is equal to 30 root 3. This is what is BC, which is asked. And we know the value of root 3 is equal to 1.73. That means 30 into 1.73, which is equal to 51.90. So as it is given in meters here, this also will be in meters. So the boat is at a distance of, what we say, 90 meters from the lighthouse. What helped us to solve this is the property of angle bisector of a triangle. The angle bisector divides the opposite side and the rest of the sides proportionally. So we took the proportion of these two sides, BC and AB. We also applied the concept of trigonometry we studied in class 9.
Now click on the subscription button below to subscribe the channel, then the bell button to get the notifications of the new videos. Thank you.